Hi, welcome to this video where today we are proving segment relationships. So before this video, you should have watched or done your lessons on all the properties that we need, algebraic proofs, starting to solve some really basic geometric proofs. We're going to have an extra postulate in here today, segment addition postulate, that we're going to basically add to our toolbox of things that we can use as reasons for doing a proof. So follow along with me. Ready? Segment relationship. The following proofs involve another special postulate called the segment addition postulate. If A, B, and C are collinear, then point B is between A and C if and only if AB plus BC equals AC. Now, we did a lesson all on linear measure when we talked about points being collinear, a point being in between another set of 2 points, not midpoint, guys, just somewhere in between. And then if that point B is in between, then AB plus BC equals the entire length AC. So that's actually not a new idea for us. But what is a new idea for us is now when we do that kind of situation in a proof, we officially give the reason for segment addition postulate. We also can use congruent statements for reflexive property, symmetric property, and transitive property. So in our previous lesson, we only did reflexive property when we were talking about the measure of a segment. Now we can actually use reflexive property for physical segments. You can always change a physical segment, the congruence to the measure the equal statement, but now we're actually putting into our toolbox. We don't actually have to do that. So that works for reflexive, symmetric, and transitive. Okay. So we have quite a few proofs we are going to go through. Let me just get my screen ready to go. I have to zoom out quite a bit. All right. Okay, everyone, let's take a look at our first proof. So here it says given AB, segment AB is congruent to segment DE. I'm just going to go ahead and mark that up so we can visually see what's happening. Then it says segment BC is congruent to segment EF. Okay, so I'm just going to mark those up. We have to prove that the entire segment of AC is congruent to the entire segment of DF. So we also have to think, okay, I'm given these congruent statements. So think about it. After we've made congruent statements, we've always talked about measures being equal to each other. So that should be like a trigger first step. We also now just learned about segment addition postulate and that the two smaller segments of a full segment are equal to the entire length. So, and then we notice that they are the same to each other. So we could probably make some good connections that way. So let's see what happens. First, we always start out with our given statement. So exactly what we are told, the reason is given. We know this. It's the easiest part of the proof. Now, what we know is that every time we've talked about segments being congruent, we've also then talked about their measures being equal. So AB is equal to DE and BC is equal to EF. That's your definition of congruent segments. So what we can also now say is we can use that segment addition postulate. And we can say, okay, well, AB plus BC is equal to AC, the entire thing. And DE plus EF is equal to DF. And that's your segment addition postulate. Now, the reason why this is going to be so helpful for us is I want you to take a look and see what happens here. Since AB is equal to DE, then where I see a DE here, I can just plug in an AB. And where I see EF, since I know BC is equal to EF, I could just substitute in a BC there. Okay, and if I do that, I end up getting AB plus BC equals DF, and that's just me really using substitution. Now, I could have actually done it the other way around. I could have plugged in DE where AB is, and I could have plugged in EF where BC is, and you would end up doing the same thing, just you're using different segments, but the end result will be the same. Now, here's the deal. Because AB plus BC, we actually already know, look, it's up here, AB plus BC is equal to AC. I can now say that AC is equal to DF, again by substitution, and that brings me exactly where I want to be. I want to prove that the segments are congruent. Well, here I have that the measures are equal, so therefore if the measures are equal, the segments are congruent, and I'm done with my very first proof. Excellent. Let's take a look at the next proof. So we are given that segment AC is congruent to segment BD. So AC, this entire segment here, is congruent to segment BD. Okay. We need to prove that AB is congruent to CD. So let's look at this here. We're given AC, which we see is broken up into two little segments. And then BD, which is also broken up into two segments. They share a segment BC, so that's going to be interesting. And we have to prove that AB is congruent to CD. Those segments are congruent. Okay. So we know the first step. We list the given. We also know that every time we've been talking about segments being congruent, notice we keep going and talking about their measures being equal. And that's always definition of congruent segments. Now, we did use the segment addition postulate in our previous proof, and it looks like we're going to need to do the same thing here because we're talking about the entire segment of AC that is broken up into two separate segments. So I'm going to go ahead and make my two statements that I can do. I can say AB plus BC equals AC, and BC plus CD equals BD, right? The smaller segment plus the smaller segment equals the entire segment. Now, notice what we are doing here. So notice that AC is equal to BD. We're saying AB plus BC equals AC, and BC plus CD equals BD. Okay, so if I say that AC is equal to all of this, and then BD is equal to all of this, then what does that say about these two expressions? Those two would have to be equal to each other, and that's on substitution. Because we replaced AC with everything AC is equal to, we replaced BD with everything that BD is equal to. Notice what they have in common, right? They both have BC in common. So we could actually subtract BC on both sides and just be left with AB equals CD. Notice they both have BC in common. So if we subtracted those out, we would be left with this statement. And now look how close we are to proving it. We want to say that segment AB is congruent to segment CD, and that's back to using definition of congruent segments. Pretty good. Okay, proof number 3. We are given that B is the midpoint of AC, segment AC, D is the midpoint of segment CE, and BC equals CD. Okay, so there's a lot going on here. We're bringing back midpoint. So we had midpoint in a previous lesson that every time we talk about there being a midpoint, that we could say two segments are congruent to each other. All right, we're also given that BC is equal to CD, that those measures are equal. We have to prove that segment AB is congruent to segment DE. Okay, so we're trying to match those up. So first of all, if I'm told I'm given a midpoint, if B is the midpoint of AC, and then D is the midpoint of segment CE, well, I can make these two statements. Segment AB is congruent to segment BC, and segment CD is congruent to segment DE, and that's your midpoint theorem, or you could say definition of a midpoint. Then we know going forward that if I'm talking about segments being congruent to each other, then I can talk about their measures being equal. So AB is equal to BC, and CD is equal to DE. All right, so now I'm saying that these two measures are equal, these two measures are equal. Now, look what ends up happening here. We are told that BC is equal to CD, right? And notice BC and CD are here. So if these two statements are equal to each other, and then we're told BC is equal to AB, and this CD is equal to DE, look at the next thing I could say. I could say that AB is equal to CD. So now look at how this jumped. So if AB is equal to BC and BC is equal to CD, then AB is equal to CD. And so that's that statement, and that's my transitive property. Now we're getting super close because look what I want to be able to say. I want to say that AB goes with DE. Well, here, CD is equal to DE. So if I know that AB is equal to CD and CD is equal to DE, then I can say that AB is equal to DE, and again, that's my transitive property. I now have the order of my statements, but I just need to talk about their segments being congruent, and I would then be able to go ahead and do my definition of congruent segments. So there was my transitive property used twice to kind of leapfrog over and make sure that my final answer is in this order of segment AB equals as congruent to segment DE. Okay, number 4. This is a long one. Okay, given E is the midpoint of segment AB and CD. Been there, done that. We know what to do. And segment AB is congruent to segment CD. Okay, so we need to prove that AE, we're trying to prove that AE is congruent to CE. We're told that E is a midpoint and that AB, this entire length of a segment, is congruent to this entire segment CD. Okay, so we know first off we state our given. Then we've seen this story plenty of times. If E is a midpoint, then we're able to say that AE is congruent to EB. And also, since it says E is the midpoint of CD as well, segment CD, then we can say that then CE is congruent to ED. So this is what we have so far. Because E is a midpoint, we can say this segment is congruent to this segment, and this segment is congruent to this segment. Okay. We are also told that AB, segment AB, the entire length, is congruent to the entire length of CD. So I'm going to be able to transfer these 3 statements now about the congruent segments into their measure statements. So AE is equal to EB, CD is equal to ED, and AB is equal to CD, because I want to now be able to use my segment addition postulate going forward. All right. So now that I have them all in their measure statements, I'm going to go ahead and start breaking things apart. So AE plus EB equals AB. CE plus ED equals CD. All right, so let me just backtrack for a moment. We took the fact that we were given a midpoint and we made statements. From those statements, we then put them into their measurement form. Okay, now we're also bringing in segment addition postulate, because remember, we have to prove that one part, that AE, that segment AE, is congruent to another part, segment CE. So in order to narrow it down to those segments, we need to talk about the entire length and then see what we can do from there. So now look at what we're working with. Okay, we've got AE plus EB equals AB. We've got CE plus ED equals CD. Now look at everything else that we're also saying is equal to each other. I mean, you can look at this and start replacing certain measures of segments with other measures. Like if AE is equal to EB, well, couldn't I throw in an EB here? And if CE is equal to ED, I could throw that in here. But also notice it says that AB is equal to CD. And notice I now say that AB is equal to all of this and CD is equal to all of this. So that could be a possible next statement, is saying, well, okay, then AE plus EB is equal to CE plus ED, and that would be my substitution. I'm substituting everything I know that's equal to AB, set equal to everything I know that's equal to CD. Okay, so now what, right? Now where does this bring us? Well, we still need to narrow it down, so we only have AE and CE. So look at this EB here. We don't want EB to be in there anymore, but look, we know that EB is actually equal to AE. And we want to prove that CE is over here on the right, but we've got ED. But ED we know is equal to CE. So again, by substitution, I can start to narrow it down to just work with the segment pieces that I really want. So now AE plus AE, I would say, is 2AE. CE plus CE is 2CE. Do you know what we're going to do next? We're going to divide both sides by 2. And then last step, if I'm given that the measures are equal, then their segments are congruent by definition of congruent segments. This was definitely a tougher proof for sure. We only get good at proofs by doing a lot of them. That's why you're seeing so many proofs in this lesson, but they definitely are complicated. Okay, we are going to go back now to proof number 5. All right, let's take a look. Given AE, segment AE is congruent to segment CE, and EB is congruent to segment ED, prove that AE plus EB is equal to CE plus ED. This is going to feel pretty similar to a previous proof that we just did, but it's not exactly the same. So we are given all those statements. Think about what generally always happens after we make those statements. We then say that their measures are equal. So that's definition of congruent segments. Then, since we are talking about, this entire equation, we want to say AE plus EB is equal to CE plus ED. Well, think about where that's really coming from. That's really coming from us using that segment addition postulate again. So AE plus EB is equal to AB. CE plus ED is equal to CD. Now, notice what we are trying to accomplish here. We're trying to say that AE plus EB is equal to CE plus ED. Now, notice that we don't have any statement about AB being equal to CB here, but notice that we do have values that can replace each other. So when you take a look at this and you see that, AE is the same as CE rather, and EB is the same as ED, okay, you'll notice that you actually could substitute that into that place. What I did next step here is I said that AE plus EB is equal to CD. So instead of substituting it in that way, I just did it in reverse. I substituted in, since AE is equal to CE, we could substitute an AE in here. Since EB is equal to ED, then I can plug in an EB in for ED here. So it doesn't matter which one you mix and match with, but now we have this statement. Now, because we have this statement here, and AE plus EB is equal to CD, and we know that CD is right here, and let me show that reason from before, substitution, then I would be able to say that AE plus EB is equal to CE plus ED, again, because of substitution. So if this is set equal to CD and this is also set equal to CD, then those two expressions would equal each other. Okay. Given segment AB is congruent to segment BC and segment BC is congruent to segment CD, prove that AB is congruent to CD. This is obviously super quick. Okay, that given. If I want to prove that segment AB is congruent to segment CD, this is basically just your transitive property. This mini proof was just put in there just to make sure we know we can use our congruent statements with symmetric property. Transitive property. All right, last one from this set. B is the midpoint of AC and C is the midpoint of BD. Prove that CD is congruent to AB. All right, so I'm going to draw a little diagram here. And we have A, B, C, D. We need to prove that CD is congruent to AB. So we are given our first statement. We know now every time we're talking about midpoint, we're going to make a next statement about congruent segments. So then I would be able to say that segment AB is congruent to segment BC, and segment BC is congruent to segment CD. And that's on our midpoint theorem. Notice that I can then say, using my transitive property, that segment AB is now congruent to segment CD. The only reason why there's one more step here is look at the order we're trying to prove it in. It says segment CD is congruent to segment AB, and that would be our symmetric property. So remember, if you have to reverse the order, make sure you use that symmetric property. Okay. So I have a couple last set of proofs here. Okay, I have two last proofs that I am going to put up on the screen and see if you can take a moment to figure them out. And then I want you to press play when you think you have it correct. So go ahead, pause your screen right now, copy down this proof, see if you can do all of your steps, and then press play when you are ready to check it. Okay, I hope you did what I just told you and you are checking your proof. So here you, of course, have your first statement. We are trying to prove that YZ is congruent to KL. So based on what we're given, we are given about a midpoint. We can then say, basically in the first statement, hey, segment XY is congruent to segment JK, so XY is equal to JK. That's definition of congruent segments. We can also make two statements based on the midpoint. Segment XY is congruent to segment YZ. Segment JK is congruent to segment KL, and that's your midpoint theorem. We can make an additional statement then about their measures being equal. So XY equals YZ, JK equals KL. Now we should notice now that since XY is equal to JK and XY is equal to YZ and JK is equal to KL, that's going to help us get to where we need to be in our proof. So one of the first steps is to say that XY is equal to KL, and that is on your transitive property. So since XY is equal to YZ, okay, and it says here that XY is equal to JK is equal to KL, then we're able to make that statement. We can also then say that YZ is equal to KL. Okay, so since XY is equal to KL and XY is equal to YZ, then YZ is equal to KL. That would be my substitution. I can replace them. And then last step, segment YZ is congruent to segment KL, and that is definition of congruent segments. You may have done things in a little bit of a different order or match things up a little bit differently, but overall it should be the same general idea. Okay. Last proof in this lesson. So again, I'm going to encourage you to jot this down and then see if you could do the proof and then press play. Okay, so we are given that segment AB is congruent to segment CD. Your job is to prove that segment AC is congruent to segment BD. We are given our first statement. We then talk about their measures being equal to each other. Okay. We are then going to go ahead and use the segment addition postulate to break it apart. So AB plus BC equals AC. BC plus CD equals BD. We are then going to be able to take, let's say, the second statement. And since we know that AB is equal to CD, we can replace the CD with this AB. So BC plus AB equals BD. That is on substitution. We can then say that AC is equal to BD because we are given the same set of information here. Notice that AC is equal to AB plus BC, so is now BD. BC plus AB is equal to BD, so therefore they are equal to each other. That is also substitution. And then we would be able to say that their segments are congruent based on the definition of congruent segments. I know this was a lot of information. Please feel free to rewatch as much as you need or drop in some questions below. Thanks for watching. Bye.